Hey, Professor Baldwin here, and today we're going to talk about variation. And variation uses a lot of applications, so we're going to have a bunch of word problems today. But don't worry, just use the clues that are going to be in the problem, and I'll help you find those. First, we're going to start with two types of variation, direct variation and inverse variation. Direct variation will be in this format, y or f of x equals k times x. And inverse will be in the format y or f of x equals k divided by x. And in both cases, k is your variation constant, or the constant of proportionality. So it's a constant. It's a number that's not going to change. And in most of these problems, you need to find k before you can move on with the problem. So, the steps you're going to use to solve variation problems. Step 1, determine what type of variation you have. So look for your key words. Step 2, write the equation, substitute the values you know, and solve for k. It is rare that k will be given to you. They'll tell you some points, and you need to find k and then use that to create your function. And then step 3, write the equation of variation and use it to find the unknown value or values in the problem. Ready? Here we go. Number 1, the Baldwins decide to give their children a weekly allowance that is directly proportional to each child's age. Their 6-year-old daughter receives an allowance of $5.50. What is their 9-year-old son's allowance? Well, what's our key word? Directly proportional. So we know we're going to have a y equals kx. Now, what do we know? We know that a 6-year-old gets $5.50. So x is 6 and y is 550. So we can substitute that in, or 550 equals k times 6. Now we need to solve for that constant k, and k will equal 5.5 over 6. And leave it like that. So now you know the function, and we can just call it f of x is equal to 5.5 over 6 times x. And you probably need to specify that x equals the age. So then we need to evaluate for the 9-year-old. So f of 9 equals 5.5 over 6 times 9. Punch that into your calculator and you'll see that that 9-year-old gets an allowance of $8.25. See, it's not too bad. Just find the clues. Number 2, the time t required to do a job varies inversely. As soon as I see the word inversely, I know that I'm going to have y equals k over x. So the time t required to do a job varies inversely as the number of people p working. So I know for this specific problem, they're using t as their y value and p as their x value. Then we're told it takes 5 hours for 7 bricklayers to build a park wall. Okay, we're going to stop there and identify our t and our p so we can solve for k. So t is time, which is 5 hours. And that's equal to k over 7. So we know k equals 5 times 7, or 35. So we know our function t of p is going to be equal to k, which is 35 over p. Now we can look at the last part. How long will it take 10 bricklayers to complete the job? Well, 10 bricklayers, that's the number of people, p. So we're finding t of 10, which is equal to 35 over 10, or 3.5, and T is measured in hours, so we know that it's going to take 3.5 hours for 10 bricklayers to finish the job. Okay, example 3. The pitch P of a musical tone varies inversely as its wavelength W. Again, inversely, and we know that P varies inversely with W. So, our formula is P equals K over W. One tone has a pitch of 330 vibrations per second and a wavelength of 3.2 feet. So we're told the pitch is 330 when the wavelength is 3.2. And we can use that to find K. Well, K is going to be equal to 330 times 3.2, or our constant is 1056. So our function will be P of W equals the constant 1056 over W. Now we're asked to find the wavelength. We have to find W of another tone that has a pitch of 550 vibrations per second. So we know that P is 550. And we need to find W. Well, this is 550 over 1, so we can cross multiply. 550 times W equals 1056. Divide by 550, and we get that W equals 1.92. But we need a unit of measurement. W is the wavelength, and it's measured in feet. So wavelength is 1.92 feet when you have a pitch of 550 vibrations per second. Good, you've mastered direct variation and inverse variation. So how about a couple more variations? You're also going to see directly as the nth power of x, inversely as the nth power of x. Those still just have two variables, x and y. And then the third one jointly as x and z. This throws in a third variable. So you have the variables x, y, and z when there's a joint. Let's try some examples. Example 1, y varies inversely as the square of x. So y inversely, so the constant is in the numerator, and then square of x is in the denominator, so that's x squared. And what do we know? We know y is 0.15 and x is 0.1. So our constant will be equal to 0.15 times 0.1 squared, or 0.00015. So we can rewrite that equation as y equals, put our constant in the numerator, and the x squared in the denominator. And number 2, y varies jointly as x in the square of z. So y equals, we have our constant times x times the square of z, so z squared. And then we're given some values. So y is 105. We're trying to find k. X is 14, and z is 5, and it needs to be squared. So 105 equals k times 350. So k then is equal to 105 over 350, or 3/10. That means our joint variation will be y equals our constant, 0.3, x z squared. See, they're not too bad. Just take it piece by piece. Let's try an application. The intensity I of light from a light bulb varies inversely as the square of the distance d from the bulb. Okay, let's stop there and write what we know. I varies inversely, so our constant is in the numerator, and the denominator is the square of the distance d, so it's d squared. Okay? And next, what do we know? Suppose that I is 90 watts per meter squared when the distance is 5 meters. Okay, let's use that and we can find our constant. So we know 90 equals K over 5 squared, or 90 equals K over 25, which means K equals 90 times 25, which is 2,250. That tells us our equation will be I equals that constant, 2,250 over d squared. Now, what do we need to solve for? How much farther would it be to a point where the intensity is 40 watts per meter squared? Okay, so this is I. So 40 equals 2250 divided by d squared. Well, that's over 1. So 40 times d squared, we're cross multiplying, gives us 2,250. Divide by 40. So d squared equals 56.25. D would be the square root of 56.25, or 7.5 meters. But be careful. This distance of 7.5 meters is the distance for 40 watts per meter squared of light intensity. And we're asked how much farther. So we know that we have 5 meters for the 90 watts per meter squared. But then it's 7.5 meters for 40 watts per meter squared. So that means how much further? So how much further does that light intensity go? 2.5 meters further. So it didn't ask us what the distance was for 40 watts per meter squared. It asked how much further. So just watch for those little tricky parts. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos.